Hey guys, so back to scalars and vectors. Okay, we said a scalar was just a size. So that just tells us 10 meters, 20 meters, 100 miles per hour. Just the size. It doesn't tell us anything about the direction. So we really are going to be working with something called vectors. Okay, what this is a size of whatever the quantity is plus the direction. So let's give you a chance to write that down. Size plus direction. So this says 10 meters south, 20 meters north of east, 100 miles per hour north. Okay, we've got to have a direction attached to it to be a vector. And in real life, guys, and what the deal is, we're going to be using vectors mostly. Scalars now just have a size. Okay, so let's just get you some examples of vectors or scalars. Time is a scalar. Distance is a scalar. Displacement is a vector. Speed is a scalar. Velocity is a vector. So speed gives us the how fast it's going, but it doesn't give us anything about direction. Velocity does give us direction. So you might have to commit these to memory. Something else that has a vector quantity would be acceleration. Has a vector quantity, is a vector quantity. Okay? Give you a second to write those down. So as you're writing those down, vectors make sense because if somebody were to ask me how to get to my house from the school, I would have to give directions. I couldn't just say go 20 miles and then go 30 miles and then go 40 miles. They'd look at me like I had two heads. So I've got to include that direction. Okay, so when we get into direction, we get into displacements. So if you want a couple of examples, here we go. I'm going to give you some examples here. Let's say I run, or a person runs 20 meters east. And then they run 10 meters west. Okay, so my first question, what would be, now I can come up with a lot of questions here. Let's say they did this in a time of 10 seconds. Okay, all this stuff in 10 seconds. Actually kind of quick, but let's see what we got. Okay, the speed, okay, so the distance, you're just adding up the numbers. So 20 plus 10 is 30. Okay, the displacement is adding up the numbers but including the direction. So if you look at displacement, 20 meters east. And then from that point, they run 10 meters west. I'm left with this much. I'm left with 10 meters east. Okay, so my displacement is 10 meters east. Okay, I might go further with that. Okay, and I might say, what is the speed? Okay, we know from the last section that speed is distance over time. Okay, I got the distance, 30 meters. I got the time, right? 10 seconds. So the speed of the trip is 30 over 10, or 3 meters per second. Okay, I'll let you write that down and kind of soak that in a little bit. That's easy to calculate, right? We get the total distance over the time, 30 over 10. Now, if I ask you what the, here's our next unit here, velocity is, okay, we're going to define velocity as displacement over time. Okay, all right, so now we'll call this the displacement over the change in time. Okay, so if we did all this in from 0 to 10 seconds, velocity equals displacement 10 meters east over 10 seconds. Velocity is 1 meter per second east. Okay, you notice now there's a distinct difference between our speed of 3 meters per second and then our velocity of 1 meter per second east. Okay, they're completely different quantities, and we're going to work with this a little bit. I'm going to give you a few problems to work out in solving for velocity versus speed. Okay, speed is the total distance, which we know is 20 plus 10 over the time. Velocity is the displacement over time. We're only displaced 10 meters. That's all we displaced. Okay, so that's a little idea of how to get that type of problem done, and you'll see this come up over and over again in the homeworks.